Within Micropole Insight, we have a particular project approach for the migration to the cloud. It's called A2C. This approach is built on three important pillars. The first one is the technical expertise. When you migrate to the cloud, the principles of handling the data are quite similar as it is on-premise, but the tools and the implementations are a little bit different. So to speed up your project at the start and to lower the learning curve, I think it's good to have some extra knowledge on board. Within Micropole Insight, we have the technical expertise at the level of architecture, engineering, and modeling. The second pillar of our A2C approach is the platform. Within Micropole Insight, we focus ourselves on the cloud platform, and more in particular on the Azure cloud. We focus ourselves on using resources of the platform as a service in PaaS, instead of doing a lift and shift of the infrastructure. The last pillar is the organization. We believe that the migration to the cloud is more than just a technical thing. With our A2C approach, we try always to go for a use case-based way of working with a small defined use cases and also followed by the same people from A to Z. Moving to the cloud also involves a mindset change. So the way of working with the cloud is, for example, more agile than it is on-premise. And this is also something you need to create awareness around and to adapt at your organizational level. If you want to know more about our A2C approach, you can always contact us, and we are always happy to provide you more information. The cloud, of course, comes with a lot of advantages, and you might already have read or heard some of them, but I want to quickly list the 6 most important ones for you. The first one is that the cloud is a project accelerator. This means that you can already focus on the use cases and waste less time on buying and setting up the infrastructure. When I did some projects on-premise in the past, those projects needed most of the time to order hardware and set up new tools. Within the most companies I worked with, this procedure take a lot of time because you need to make estimates, you need to get budget, all those kind of things. When you start in the cloud, you can already start with a small amount of money and setup and a small amount of setup time. So you can really accelerate your project. The second one is the experimenting in lab mode. This is a totally new mindset. On most of our Azure projects, we start with 1 or more POCs or MVPs, which can be quickly done just in a few weeks, and it shows you already the benefits and in some cases also some impediments that needs to be solved. But this lab mode can also support in describing and fine-tuning your business or your functional analysis. The third one is the lower total cost of ownership. You pay only for what you use. You can start small and let your environment grow organically. When I did my first big data projects, like more or less 6 years ago, it was on premise with a PDW, the parallel data warehouse. And this PDW appliances already costed like nearly $500,000 for the smallest topology, like quarter rack in a 2-node appliance. This appliance was delivered by one of the hardware vendors like Dell or HP, and it was managed for you. But you had to put all the money on the table up front before you could even starting to write your first line of code. The next one is the increased agility. Working with Azure gives you the ability to use untapped data like streaming data, partially structured data, unstructured data, and it makes it easier to make actively changes to your need, especially with a specific design of your integration layer. We, for example, at Microsoft Insight, we use a lot of data vault modeling, which can be used for your integration layer. The next one is the high scalability. You can adjust your environment to your needs at any time. So you can start very small, like with an MVP, and grow step by step. But you can also get extra resources at peak moments. If you have a monthly or a yearly closure, or if you have a peak moment, if you have a new product that is launched, then you can get those extra resources. Customers ask me sometimes, what are the limitations? And most of the time I need to answer, your wallet is. And this is an important point because you can keep on scaling your environment, but you need to define thresholds and still keep on monitoring what you do, because otherwise the amount might become too big. But because the people need to spend less time on maintenance, like patching and those things, I believe they can work more on the functionality and also on monitoring your environment. The last one is the high availability. You can minimize your IT disruptions through redundancy, fault tolerance, and also the failover protected components. Additionally, you can make your data geo-redundant and have your data active in a data center that is the closest to your place. In the Azure cloud, there exist a lot of services to convert data into real wisdom, step by step. Everything starts at the bottom level, at the operational technology level, with the raw data, which can be, for example, sensor data of your machines. In a second step, if that data raises an event, for example, it becomes information which can control and collaborate with other services. As a third step, and it's the first step of your IT layer, this data gets processed and centralized, so people can get an overview of statuses, can combine the data with other data, and can get, for example, also a 360 overview. In the last phase, we can apply AI, for example, machine learning on it, which can give you predictions or algorithms to do real advanced analytics. Now we have already a quick question for you in a poll. And the question is your company running already on Azure? Normally, you should see the answer box. Okay. I'm waiting for the results. There's still one person, I think, 6 people that need to answer. Let's wait for a few more seconds, but okay. Okay. With all those new components and methodologies, there is also. Okay, now I see the results of the poll. Sorry, I see that. And I don't see the number at this moment. I see that most of you are already partially running on Azure, so it means like half of you of the people are already partially doing things and maybe are already in the process of going to the cloud, which is a good thing. Okay, with all these new components and methodologies, there is also a new way of doing architecture. Together with the cloud way of working, which offers you a complete new set of resources, you can also start doing data flows and this architecture in a different way compared as what you did on premise. When I started doing my first cloud project 4 years ago, I discovered also a new approach of data delivery. One of those new approaches was the Lambda architecture. The Lambda architecture contains 3 layers, 2 layers to process the data on the left side, and 1 layer to deliver the data or present it to the end consumer. On the top left side, you see the batch layer, which will process the data and pre-calculate data that can have some latency. For example, master data, HR data, orders, that kind of stuff. On the bottom left, we have the speed layer. This is a streaming layer. That is data that has low or can have no latency at all. On the right side, we have the servicing layer, and this can virtualize and optimize the data to give it back to your consumers. And now give the word to Glenn, who will dive deeper in the architecture and match it with the Azure components.
Thank you, Egon, for giving us an introduction about Micropol's A2C approach and giving us some more explanation about the Lambda architecture. This is very useful because our architecture blueprint is based on this Lambda architecture, and it's also based on the experiments that we have with such implementations. During the presentation, the webinar, we will issue some recommendations and describe some best practices around this architecture blueprint. I will go briefly through the different building blocks of the architecture blueprint and describe their function. First, you got the data lake layer. This is our storage account, and it will be our main repository. We typically work in 3 or 4 different zones, depending on the customer's needs. And for example, it exists of an raw, archive, and expose layer. We also can have some real-time ingestion in there, and we can stream this data also to the data lake if needed. Next, we got the data integration layer. What is interesting about this layer in our setup is that we use the Data Vault 2.0 modeling technique. So it's a modeling technique that is based on the third normalized form and Kimball, and it combines them so it gives the best of both worlds. It has a lot of advantages, like for example, it is capable of dealing with cross-platform data persistence. It can also handle multi-latency and multi-structured data, and Data Vault is very strong in massively parallel platforms. Last but not least, it's also very agile. So in the past, I had a problem during a project where we had some slowly changing dimensions on the source, and we have some slowly changing dimensions in Azure, and we couldn't figure out how to solve this issue. And for this, Data Vault came to a solution and brought us the correct result. I'm not going to go into deep about this modeling technique because we also have a next webinar in 2 weeks about this, where my colleagues will explain more in detail. The next layer we got is the data science layer. This is the layer where we can do some machine learning, some forecasting, artificial intelligence, etc. And all of this stuff will be considered as data science for us. Next, big data. So for specific data processing jobs, we require a Spark or a Hadoop framework, and we can use it in this layer. Then the speed layer, very important as you go to Azure, because this is something that on-premise is hard to solve most of the time. And it's getting a single-digit millisecond response time and getting maybe 99.999% availability, and also scales automatically and instant. So very interesting to do in the cloud. Then we also have the information delivery layer, in where we will present the data and send it to the applications or to the users as reporting purposes. Now I will give you an example of the components that we think that in Azure can be used to do this. I will not describe them all right now because I will go into detail a little bit more layer per layer. So first, we'll start with the data lake layer. And we recommend using Azure Data Lake Gen 2 for this. It's a storage account, and if analytics is your most important need, then this is the way to go. If not, maybe an Azure Blob Storage can be used as well. One of the advantages, for example, of the Data Lake Gen 2 is that it has hierarchical namespace. This namespace is coupled with a distributed file system and as an endpoint, and this is what enables the high performance and gives you some security improvements. Also, for streaming and IoT data, we recommend Event Hubs. Event Hubs provides a distributed stream processing platform with low latency and seamlessly integration. And of course, like almost every component that we are going to work with, Event Hub is fully managed platform as a service component, like Egon told, a PaaS service. To go a little bit more into detail about the Data Lake Gen 2, so about our layer, what we are going to do with it. So it's a corporate data lake. It's a centralized repository, and it allows us to store all the structured and the unstructured data at any scale. Its purpose is to collect raw data in native format under the form of files or real time, like I just told you. We can also start exposing this curated data for consumption or exploration. And we're also going to keep history here, because given the limited cost of the raw object storage, we strongly recommend keeping history in the data lake. Beware, the data lake should be as much as possible the unique landing zone for all the corporate data. But we have some key drivers and some main challenges that goes with it. So in the left, you see 5 key drivers. One of them is collect and consolidate, so we can avoid silos. Next, we got the ability to scale, speed, and access to the data. So the time to market is very low. We can start exploring right away. And it goes hand in hand with the third point, that the support analytics and advanced management self-service, you can connect from reports to data lake, you can connect from Power BI to data lake, and you can start exploring very, very fast. But also we got some challenges, of course, with it. Data lake can become a data swamp if there is no proper metadata management. And this is a little bit harder to set up. This is something you have to set up for yourself, work with other Azure components. So this is not out of the box. Also, the governance and the monitoring can be sometimes a little bit hard to handle. It's more difficult to align with the business goals as well. And like I said, it can become very big. Next, I will go into the other layers. So the data integration layer. For this, we recommend using Azure SQL DB or Azure Synapse. This will be based on the use cases, the sizes of the tables of the databases, the volumes. So we will go sit together and then we'll see which solution is the best for your use case. Next, we got the data science layer. For this, we recommend Azure Machine Learning or Azure Databricks. Most of the time, it's just the flavor of the customer and in what they like to work with. So we leave it both open for discussion, but we feel like they are both equally good. Next, we got the big data layer. I put in here HADE Insight because a lot of customers have in-house experience with Hadoop, but for us, we recommend Azure Databricks. So this will be our main focus. And last but not least, the speed layer. For this, we recommend using Cosmos DB. Any other options that are available are streaming analytics or as well Databricks for some minor speed layer options. A little bit more into detail about what it should do. So Egon told us about the Lambda architecture. Here I'm going to show that 3 of our layers are in the batch layer and one of the layers is in the speed layer. Our data integration layer is typically in the batch layer. And what should it do? It should provide some subject-oriented data. This means organized around major business domains or business concept. We can also integrate data to provide a consistent and reliable source. And for this, we can use like reporting or analysis. Or we can also make available the non-volatile data where the history is retained. And for this, we can support consistent reporting for past business events, so from history data. Then we also got the big data layer. So for specific data processing jobs, we are going to require a Spark or Hadoop framework, and we distribute the workload and offer a sufficient level of performance while also keeping the costs under control. And we feel like Azure Databricks is a recommended component for this. The data science and artificial intelligence layer. So this stack will leverage different tools available on the platform. It will support implementation and deployment of advanced analytics and machine learning use cases. Here we can go for various types of machine learning services like pre-trained models, for example, text or image recognition or speech to text. So those tools can be accessed through APIs and require no setup or infrastructure at all. We can also start with training our own models, and then we have a dedicated framework that can be used, such as a machine learning service or a machine learning studio, and we can also use Azure Databricks for it. Then under the Lambda speed layer, so in our blueprint, it's also called the speed layer. This will allow you to ingest, process, and expose data in real time. So the purpose of the speed layer is to ingest streaming data from one specific source. we are going to enrich it on the fly, and we are going to push it to a low latency database. Beware, a speed layer is not intended to integrate all the data from all the systems in real time. This is not something that we implement. And we feel that Azure Cosmos DB is often used to implement the speed layer. Next, we got another poll. So if you would go to the cloud and you would start with Azure, which is the layer that you think you would use first? So for your first use case, would you think about using the speed layer, the data science layer, the big data layer, or the data integration layer? I'll give you some time to answer. It's a little bit harder than the previous question.
Yeah, indeed. It is.
Just a few more seconds. Okay, the poll is over now. So we can see that most of the people would start using the batch layer. A few of them have told us about the big data layer, which I think is more interesting because this is something that you wouldn't handle at the moment, or you can handle at the moment on premise, but that it's interesting to go to the cloud. So when we are going to the cloud, typically we're going to use for some use cases that we cannot solve on premise, or something that looks a little bit more sexy than the batch layer. So the batch layer, we are going to do it eventually, but as a first use case for us, we would go more through the big data or the data science stuff or something like that. Okay, next we got the information delivery layer. So this is the last one I will talk about. Here we got also matching with the Lambda architecture, it's the servicing layer. And for this, we recommend using Azure Synapse. The other possibilities is Azure Analysis Services or even Power BI. Power BI, why would we use that? The new method of Power BI is that we are going to create a data set in the Power BI report, and then we're going to make that data set available for the other Power BI reports. So it's kind of using Power BI as a cube, in fact. So that's the new way of doing Power BI, and that's why we even suggest it as the servicing layer. But what does the layer needs to do? So the data needs to be delivered in different ways, and one of them is a corporate or departmental data mart for reporting purposes. We also have the operational data stores. This is for presenting our integrated data to the users or the applications. We are going to have some APIs, which will trigger a query on one of the layers. We will have some APIs exposing a machine learning model. We can have some messages in there where events will be pushed to a queue. We also have the low latency data source, such as a NoSQL database, and storing events loaded in real time and offering excellent performance for high concurrency querying. So okay. I will give the word to Egon now.
Thank you, Glenn. So as I already told you and mentioned, going to the cloud is not only a technical thing. Also other factors are involved, like, for example, processes. They can and they will change when you migrate to the cloud. The way of doing things will change in most cases, and we try always to support also in guiding customers in these changes and challenges. On the technology, there is also, we try to avoid always a pure lift and shift to the cloud. This can be done in the first phase if needed, if it needs to be done quickly, but you can benefit more from the cloud if you adapt and optimize the way you do things to the way the cloud components behave. The third one, and often forgotten, are the people. If process and technology change, people have to adapt and to be involved in the changes and in the process too. At this level, it's, I think, very important to communicate and inform people clearly. The last one is the organization. The whole migration needs to be adapted to the way the organization is structured and organized. And this is a little bit different in every case. So there is no one solution fits all. but every organization and sector has its own specific needs and way of working. These needs can be taken into account while we do the project. With our Micropole A2C approach, we work in an agile way, where our consultants take a specific use case really from A to Z, from the analysis and getting the scope until the delivery and production readiness of the use case and validation. This way of working makes it possible to go through all phases step by step with a specific focus, without going with a big bang transformation, and it can be organized in phases which are really in cooperation with the people and the organization involved. You can also start, if you want, with a hybrid solution where already a part is going to the cloud and the other part stays on premise, and then you can do it, go it step by step. Okay, so we reached the end of our presentation. So we now have time for the questions. Let's take a look at those questions. I see one of the questions is, what are the minimum costs for starting with this approach? I think if you go to the cloud, you can start already, if you didn't try it before, with a free account. You can get it at Microsoft, and you can start for 1 month with $200 of budget to spend, and you can already play around with those components. And afterwards, you have to go for a pay-as-you-go or another kind of offer, and then you have to pay for it. But you can start really small and then let it grow. If you want, you can also calculate on the website of Microsoft. You can see some calculation tool where you can really fill in the amount of data and resources you need to process this, and then you can already have an estimation of the cost that it will be. Let's take a look at the next question. The next question is, our company is located in several countries. How secure is it, and this approach, and in terms of on downtime? Okay, so I think with Microsoft in the cloud, Microsoft Azure, you have high availability at different levels. You have high available sets, zones, and regions, and you can start already with high availability sets where you have your data redundant in one data center. If you go to zones, it's made redundant over in one region in multiple data centers. And if you go to multiple regions and make it geo-redundant, then you can also make region pairs where you can make the data available at the location the closest to you.
Yes, indeed, Egon. So for the availability and the downtime, we most of the time go in discussion with the customer, and depending on where you want to have the information. And so we go into discussion, and then we'll see if you have the need to have it high availability or have it in multiple regions. And depending on which components that you want to have in high availability, you're going to see for the proper solution. You can have a backup region. You can have, for the data lake, for example, you can have the geo-redundant information. So there are a lot of different options for other components. So depending on what you want to do and which needs to be high available, you choose for the best solution.
Okay, let's take a look if there are further questions. No, I don't see any questions anymore. Okay, then we hope that you have now a more clear view on how the Azure Cloud, together with our Micropole Insight approach, can give you added value to your organization and the way you set up your data platform. If you have more questions afterwards, you can always contact us. You can do it via mail, phone, or LinkedIn. And after this session, you will also receive an evaluation form, and we are already looking forward to get your feedback, positive and negative. Every feedback is welcome. So we hope to welcome you also on our next webinars. The next one is the one on Data Vault 2.0. It is within 2 weeks on the 15th of October. And then I would say, okay, thank you for attending and see you hopefully next time.
Thank you very much.
Bye.